Let's come back to this chart that we kind of skipped over yesterday. This table shows the properties of the sun and 5 stars close to the Earth. So we have the sun, Proxima Centauri, Alpha Centauri A, Barnard's star, and Sirius A. So this table tells us about the distance in light years, the size compared to the sun, the solar mass compared to the sun, and the luminosity or brightness, the amount of light that the star produces. Okay, so looking at this first column here, where we have these stars, the distance in light years goes from the closest star to us to the furthest star away. So Sirius A is 8 6/10 light years away, whereas Proxima Centauri is only 4 2/10 light years away. So this is the closest star after the sun. Now remember, the sun is the only star that is actually in our solar system. These other stars are in other further away solar systems. Still in our galaxy, the Milky Way, but not our solar system. Okay, next we have the size, relative size of these stars. Sirius A is both the largest and the heaviest, 1 7/10 and 2. These are the biggest values in this table for size and mass. Proxima Centauri is both the smallest and the lightest. Interestingly, Barnard's star is the most dim, or producing the least amount of light of all these stars. Remember, stars don't go away during the day. It's just that the light from the sun is too bright to see them during the day. Even the light from a full moon can prevent you from seeing faint stars. And you can see the most stars during a new moon night when the moon is completely dark. This next chart shows us how to classify stars by their luminosity or their brightness. The surface temperature of a star is related to its color. The hottest stars appear blue in color, and the coolest stars are red. Stars with mid-range temperatures are white, orange, or yellow. So these are like the medium hot ones. The sun is the closest star in our solar system, and it appears to be yellow. However, in reality, the sun's most intense emission, meaning its brightest light that it makes, is actually in the blue-green part of the spectrum. And we see the color yellow because Earth's atmosphere, meaning the gases that surround the planet Earth, and the way our human eye perceives light changes its apparent color. So the way we see the sun is not actually its true color. Isn't that amazing? The sun's temperature is about 5,800 Kelvin. Kelvin is just a different way to measure temperature than what we're used to. We're used to measuring temperature in Celsius or Fahrenheit. And Kelvin, this is a unit of measurement that scientists use a lot. A star's surface temperature is compared to the surface temperature of the sun. If the star is more red, then it's cooler than 5,800 Kelvin. If the star is more blue, then it's hotter than 5,800 Kelvin. So pretty much whenever scientists study stars, the sun is the standard that they're comparing any given star to. So we can put, if we take a look at the spectrum, we can put one of the types of stars that we learned about yesterday, the red dwarf. Red dwarfs are about half of the size and mass of the sun. Red dwarfs burn fuel very, very slowly, so they have really long lifespans. They live longer than any other type of star. But they also are one of the coolest types of stars. Here's some more facts about how stars burn their fuel to create energy. So stars are usually between 1 and 10 billion years old. At the beginning of a star's life, it radiates energy created from nuclear fusion, which is a process that takes place in a star's core and involves hydrogen fusing together and burning to make helium. As a star nears the end of its life, it begins to change the helium into heavier chemical elements, such as carbon and oxygen, and this causes the star to change in color, density, mass, and size. So next time, we're not going to have science next week, but the week after that, when we continue with science, we're going to be learning more about the life cycle of stars, how to classify stars, and types of stars. For today's assignment, I want you to make your own version of this diagram that shows how to classify stars by their temperature. Coolest stars, creating the coolest temperature, emit red light. The hottest stars emit blue light, and then the mid-range stars are orange, yellow, and white. So just make your own version of this in your science notebook. Take a photo of it and upload it to Schoology. And that's it for this week.